Greetings and welcome, friends! It's 8.3 that we're talking about today, even though it says 8.4 up there, but that's just the number of the theorem. That's not the number of the section. So section 8.3, today we're proving triangle similarity by side, 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 and side angle side. Here we go. Here's a theorem for your face. It says, if the corresponding side lengths of two triangles are proportional, all right, then the triangles are similar. Okay, so if I could make a ratio between their corresponding parts, smallest to smallest, mediumest to mediumest, largest to longest, and those proportions were all equal to each other, then the triangles are the similarist. All right, so that makes sense. That's good. Do you believe it? Does that feel true? That feels true. If you don't believe it, page 437 apparently has a proof. Let's see, here we go. All right, is either triangle def or triangle jj. I feel like that would be a great Khajiit name for Skyrim. Are either of those similar to ABC? Okay, hey, wow, look at what they did. They even like color coordinated the numbers for us. Not on your sheet. But I would compare smallest to smallest. So is 6 to 8 the same as mediumest to mediumest, 9 to 12? Is that the same as longest to longest, 12 to 16? And let's see, 6 to 8, that's 3/4, which is equal to 3/4. Which is equal to 3/4. So therefore, I would say triangle ABC is similar. That triangle symbol is like way out of whack, but that's okay. I'm keeping it. Actually, they did give us the right sequence, DEF. Okay, so that works. How about this guy? Let's, once again, set up a proportion. And the reason this was true, by the way, was side, 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 similarity theorem. So it's SSS is the acronym for that. Let's compare littlest to littlest. 8 to 8. Uh-oh, I don't think this one's going to work. Mediumest to mediumest. And longest to longest. And so the answer is no. No, just no. It's not. Not similar. Their similarity ends when they were triangles, and that was the only similar thing between them. So yeah, so there's that. Let's see. Let's verbally walk through a proof of this. I'm not gonna write it all down. But and you guys don't have to either. So, yeah, okay, I did at least put this on your paper. So let's see. It says if these are similar proportions, okay, so RS is to JK, all right, as ST is to KL, and TR, okay, is to LJ. All right, given. So it looks like we've got the this triangle, this little side triangle is similar to the big triangle, is what we're assuming. All right, but I can't assume that yet because I'm trying to prove that similarity theorem. So now what they did here, they plotted point P along RS such that P to S is congruent to J to K. Does that seem feasible or possible? Can you imagine a point along the side of the larger triangle side that would match, right, those two? Does that make sense? Is that feasible? You guys with me on that? All right, I got one head nod. I think that'll count. All right. So there we go. Now, since I have that point, it is possible to construct a parallel segment. to this other side here. So imagine a parallel segment through that like so. You agree? Yes. Now, because it's possible to draw a parallel segment, then I could then use corresponding angles theorem, and those two angles would be congruent. I could use corresponding angles theorem, and those two angles would be congruent. And I could then say that triangle RST is similar to triangle PSQ. Okay? You guys agree? And the reason I know that is angle, which I already know. Angle, similarity theorem. And since these two are similar to, you heard I was almost going to say congruent. You guys heard that, right? But it's similar. They're not congruent. Since these two are similar, and by CPCTC, these angles are going to be congruent to each other, and therefore these two are going to be similar as well, and the big one, and there's everybody's similar. Everybody's similar. Just everybody. Okay? So it is possible to prove using just side that I can set that up. I can done set that up. Good. All right, so let's jump into you guys know what's coming next. They're gonna throw some algebra in your geometry. Hooray! And they even gave you a hint as to what we're going to be doing next. We're going to use the Similarity Theorem. Find the value of x that makes the triangles similar. Ooh, this one's actually pretty good, and I don't think I gave you enough space to do it. So I should compare medium side to who? It looks like these are in matching orientations to one another. So I'm going to say x minus 1 is to 18 as... Now I could say 8 is to 3 parentheses x plus 1, but that looks like that'll get complicated. Will I need to consider that? Actually, wait, could there be multiple solutions? Guys, there could be multiple solutions here for x. All right, this just got interesting. Or I could compare the 12 to the 4. That seems like the easier way to do it. All right, or I'll say more specifically the 4 to the 12. All right, so x minus 1 over 18, 4 over 12 reduces to 1/3. Let's see. Where's my scroller here? Multiply both sides by 18. That was harder? This is the easy way. The hard way is the one where I would have had both x expressions. Oh, yes. Yeah, you could have cross-multiplied there as well. Either way you solve that is fine. The proportion is what matters. And even with proportions, there's actually a whole bunch of different ways you could set this up. So let's see, I'm just doing it this way. X minus 1 is equal to 18 divided by 3 is 6. And then add 1 to both sides, I get x equals 7. Now, is that the only answer, though? Now watch this. What if I set up a different proportion using this x expression? 3 times the x plus 1 over the 8. Let's set that equal to the 12 over the 4. Yeah? Let's reduce... you could distribute it. There's a whole bunch of ways you could solve. You guys are algebra experts. 12 divided by 4 is 3. Check this move out. Ready? I'm going to... Watch this. I'm going to 2 birds, 1 stone this. 3/8, if I multiply by its reciprocal, 8/3. Oh, man, no, you didn't. You guys see how smooth that move is? And I got x plus 3 is equal to those 3's cancel out, 8, and I get x equals 5. Hey, 2 different solutions? No. That means that there's multiple values of x that would make these true. If we doubted this, I wonder if your book did that. Oh dear! Guys, it just broke the fourth wall. If we doubted that, we could actually do a check where we figure out what each of those values of x would give us as side lengths and see if those actually set up, but they do work. Interesting way to do this. I just want to point out, I could have compared the 3 times the x plus 1 to the 8. And I could have compared the 18 to the x minus 1. And if you cross-multiplied this, you would have ended up with a quadratic equation, which you could have solved using completing the square, quadratic formula, or factoring. In this case, I suspect it's factorable because it has... I just forgot what those numbers are called. Those are whole numbers, but it even works if they were rational numbers. Yeah, question, Tyler. Oh, man. You got me. That's a 1. Man. Oh, and now this problem is far less interesting. Man. Yeah, so it was the same solution either way, and this... Okay, you got me. I was just intrigued at the possibility of there being multiple solutions, but it turns out there were not. Thank you with the save, though. So, let's, thank you. Thank you. With the save, so only one type of answer. All right, how about this? What? Side angle side? But for similarity? Wow, guys, we could call this SAS. Wow. I love it. The SAS theorem. I like it. If an angle of one triangle is congruent to the angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. All right, so notice the fact that it says included there is significant, right? That the angles have to be in between the sides that we're talking about. Actually, guys, I just thought of a super clever way of doing this. Because I can't use my congruent marks. Guys, watch this cleverness. Oh, what? No. I've never seen that notation before, but I think it makes perfect sense. Right? Oh, yeah, it looks like a cool, like... Yeah, I could turn this into like Hey Arnold or something. Alright, alright. So, yeah, so you get the idea. So it's a theorem with the side angle sideness going on. Ooh, guys, I don't know if you knew this, but Bear Grylls would be able to help you out with this next problem. What's Bear Grylls' real name? I can't remember. Actually, I do have a pair of Grayer bills. I can't. I've given myself the giggles. Oh boy, that's hilarious. I have a pair of his like crag hopper pants that I got for Christmas like 4 Christmases ago. They're pretty good pants. They allow you to hop the crags. All right, you are building a lean-to shelter. Starting from a tree branch as shown. You can construct the right end. I'm assuming this is what they mean by right end. Okay. To the left end using angle measure. Can you construct the right end so it's similar to the left end using the angle measure and the lengths shown? Huh. That doesn't seem like a helpful or necessary thing. Okay. So do I have two congruent angles? Yeah. Yeah. I've got corresponding side of, let's see, is 6 to 9 the same as 10 to 15? Is that the same? 2/3 equals 2/3. So, yes. They are similar by side angle side. But I don't know why you would want two similar triangles for your lean-to shelter. Congruent would be more helpful. Unless you were building it on a slope. Like imagine this was like a hill going this way. 6 is to 9. 3 goes into 6 twice, into 9 thrice. 5 goes into 10 twice. Yeah. Yeah, because, yeah, that's a good point. I don't know. This is, if I was Bear Grylls, I wouldn't care about similarity. I care about survival. But also, to be honest, I'm more of a fan of Les Stroud than I am Bear Grylls. Even though I don't own a pair of Les Stroud's pants. Unless I could find out where he's, like, filming next, and then just, like, show up and steal his pants when he's sleeping. That would be awesome. Like, wow, that would be so cool. Yes. Let's see. Explain how to show that the indicated triangles are similar. All right. What are your guys' thoughts on this? Friends? Friends? Question 3. Can I prove these triangles are similar? Shh. Ladies, gentlemen, please. All right, let's compare longest to longest. And mediumest, or actually longest label. The longest would have to be the hypotenuse, you're right. So that was mediumest to mediumest. And let's ask the question, is that ratio the same as the 18 to the 24? Okay, 6 goes into both of those. 6 goes into 18 3 times and into 24 4 times. And 7 goes into that, 3/4. So these sides are similarly proportional to one another. Man, that's actually the hardest symbol I've ever tried to draw. And then I've got this angle here. Oh, it looks like side angle side similarity, SAS. Oh, nope. SAS. Right? Yes. Also, I want to point out, because this is a right triangle, if you guys knew the Pythagorean theorem, which according to 8th grade Common Core standards, you do. Maybe even 7th grade, I don't remember. You could have found those hypotenusi and then used side similarity. And that also would have worked. How about this one? Question 4. This is weird. All right. Let's compare smallest on the bigger triangle, 12. Which is the smallest on the little triangle? 9. Okay, so this one is like a rotation and then scaled down version. You guys visualizing that? So 12 is to 9, and then, hypotenuse to hypotenuse. That's a good one. But I would need to do 20 to 15. And the question is, are those equal? 4/3 is to 4/3. And actually, I could even then compare, is that equal to 16 to what? Or actually, no, I would have to do 12 to 16 to 12. And that's also 4/3. So this could have been done using side angle side. Or sorry, side. Or I could have also realized that right angles are congruent, and then side angle side would have also worked. So multiple ways to prove similaritiness. Let me give you a quick little summary of our similar triangles. This is a great little graphic. Here, settle down with your... Not helpful. Triangle similarity theorems. Angle, angle, side, 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 angle, side. Those all work. It might be worth investigating at some point and ask this. That would be intriguing. But I'll let you guys investigate that at your own, on your own. But yeah, so there we go. You can prove triangles similar now. You've got a few tricks up your sleeve. Thanks for watching, Internet friends. Have a great day.